A multimeter is a must-have tool for any repair shop, but not only, for anyone playing with any kinds of electronics. In addition, having a multimeter perhaps in your car, in the trunk of your car, or just have it handy in your toolbox can save you a lot of trouble, because this is what's going to tell you the basics, the voltages, resistance, and some other stuff, perhaps current flow. But you can go around having an oscilloscope, the ESR meter, but multimeter is something you need to have. So let's take a look at this one. Hello friends, welcome back to the bench. So I'm not sure how to pronounce it. Aneng. However, they have plenty of multimeters in stock. They sell on eBay, on Amazon, and this is their newest model that just released. So let's take a look at it. Now, this is the device that seems to be packed with features. So typically, what we normally use is the diode mode, right? The voltage drop, the voltage, DC and AC, resistance, and the beeper. That's typically all you're going to use in regular day-to-day work. Less common, the capacitance meter. Sometimes it is handy, especially working with power supplies. The frequency meter, it's not going to replace an oscilloscope, but sometimes it's very handy to have it. The current meter, we have both high and low current meter. The low current meter is especially useful. The high current meter, typically the multimeters only allow you to measure high currents for, I don't remember, like 2 seconds, 5 seconds, something like that. So I almost never use the high current meter, but sometimes, especially in automotive applications or working on the cars, sometimes you want to just see how much current is going somewhere, especially when your fuse keeps blowing and you want to see how much current is going through that fuse. So instead of the fuse, you connect the multimeter, and you can detect whether it's a full short circuit or it's just slightly above the fuse. But this is typically what we're going to use. Nice message from the manufacturer. All right, let's open it up, see what's inside. Okay, we have probes. Oh, and this is especially curious design. Let's take a look at it. It's already in its little sleeve and its little holder, so that will likely make it nice to carry. And we have second set of probes, and I can already tell I'm gonna like these ones more than these. Feel nice. It's not as cheap, what do you call it, the insulation as you normally see. This is nice and soft, but you know, with as far as the probes, typically you don't use the probes that came with the multimeter, and the reason for that, you can see I use Fluke, right? But these are not the original probes that came with it. Right, I ordered them separately, and obviously probes is something that you need to replace once in a while because they're going to wear out. But this is the silicone cable, so it's very nice, and the probes are needlepoint, and this is what I use for my work, or what I need for my work. The meter itself, we'll talk about the meters themselves, but let's first see what we have here. Typical stuff. Obviously, we never read manuals. The meter should be designed in a way that a experienced engineer or technician should be able to use it right out of the box. We have mode adjust and switch to Fahrenheit and Celsius. Very neatly packed. Let's see if I can do it without damaging the meter. Okay, without batteries, it weighs next to nothing, but that's typical for meters. Pretty much all of them. Oh, other than Fluke. The Fluke I use is heavy. It feels like a big device, but it's only because it has a steel frame inside, which typically is not needed, and especially since these are produced in China, you know, you pay for each pound. So it's better to produce devices that are lighter rather than heavier. Now, I was expecting this one to be rechargeable for some reason, but I guess this is a different model. I know they have models that have lithium-ion batteries in them, and you recharge them. I've never seen any multimeter like that, and I was kind of curious how it would work, how long does the battery last. But typically in multimeters, I'm not sure. I would say I replace the battery maybe once a year. So, and the meter will tell you that the battery is low. Okay, so first what we have here, this is actually, so this is the second meter, or the improved version of it. The first one that I was actually curious about, and I was contemplating buying it, was sitting like this. That's how you read it. But the probes are connecting from the bottom, right? So, which means you can't really, you have to use it like this. And typically you want to have it standing on its little leg like this, and that's how you perform measurements, right? So they solved the problem by just flipping it this way, which is perfectly fine. Now, select. Yep. Okay. So we have DC voltage, AC voltage. I can hear the relays clicking inside. We have a resistance meter. We have a beeper, and we have a diode. And this is capacitance, frequency, DC current. So yeah, and auto. Okay, so one button to switch all the things. Here we have backlight. What was it? Yeah, we have backlight. You hold down the button to turn on the backlight. Very nice touch. Some meters have it, some meters don't have it. Fluke does have it. I never use it because I always use it on the bench. But if you're working in less lit environment, then that becomes pretty handy. All right, so now we also see that we have 60% of humidity, and it's about 26 degrees Celsius in my shop. I did not know I had such a high humidity, but it's a rainy day today, so that makes sense. And let's connect first. Let's check out these probes. I saw them on the pictures, and I was very curious because they are modular, which is a very nice touch, I would say. I've never had any of these yet. Okay, but they, how do we do it? Oh, I see it now. Okay. So on both sides of the probes, we have the same connection, right? And we can either screw in this, which is the probe on one side, and on the other side I expect this one. The banana plug, which should be the same as this. And let's see if we can plug it in. Where's the input here? Oh, nope. That's not how you do it. Or I just need to use more force. Yeah, okay, I just need to use more force. When it's new, it's kind of typical. And we have one extra, no, actually two extra bananas. I'm not sure if they are called banana plugs. I always called them banana plugs, and in Poland that's what we used to call them. But I'm not sure. Okay, which means now we can just replace these, right? So the cable can stay. And likewise, we can only replace the cable. It's very nice. In addition, this is especially nice for measuring current, right? We screw these on and we can screw it on to whatever we're measuring and have reliable measurements instead of just sticking the probes, right? So that's a very nice touch. We can connect this directly as well. Yeah, very interesting. I was kind of expecting that this would be replaceable too, but you can replace the whole thing, the whole probe, the head of the probe. Okay, so this is it. So first, we are on auto. Let's see. Oh, that is a nice touch. So you're measuring resistance, and if the resistance is low, it's gonna switch to the beeper. Very nice. But I never use automatic modes for anything. So let's see the resistance of the probes. Oh, look how fast it is. That is pretty impressive, actually. They might not be screwed on tightly, and that's why. Yeah, this is very nice. Very fast. But sometimes it goes really fast to 0, and sometimes it just drops to 0. I'm used to this dropping to 0, not exactly catching 0 like this. So this is pretty fast, which means, let's get the beeper. Oh, this is impressive. Now, why is this important? This is especially important when you're analyzing some board which you do not have the board view, no schematics, which is typical with ECMs perhaps, well, ECMs especially. You just want to go through the chip like this and find which pin is connected to it. The probes are not exactly made for it because they're a little bit too fat, but that's not a problem of the multimeter. Let's try maybe here. There, right? So this is very useful when you're searching for where the circuit is going. Very nice. Now let's see the voltage. Okay, here we have okay, let's actually check this. So this is a, I think, Schottky diode, I'm not sure, but none of my meters have the range to actually show me the voltage drop on this. So let's see if this one does. Oh, and look at that. In my, what do you call it? Let me check on the Fluke, because I'm not sure if it's actually this one, but let's see, the same measurement. It's showing 1.9. This is reverse, right? And in forward, 0.5. Okay, let's check on this one. Forward should be 0.5. Yes, and reverse shows nothing. Okay, so, well, you know, this is typical. Typically, these diodes, they require different kind of meters. So this is not disqualifying factor by no means, but looks like my Fluke is showing nicely 1.9, which is roughly the limit of it. I think 2 volts is the limit for this meter. That's why they usually have higher voltage drops. Let me try one more time. Nope. So the diode mode is slightly more limited than the Fluke, but as I said, that's not a limiting. That's not a big factor. Typically you don't measure diodes like these. Let's see the capacitance in circuit. I'm especially interested in that. These are small caps. You have to hold it for a little while, and we have 68. Very nice. It should be 47, but don't mind that. And again, hold it for a little while, and we have 343, which should be also 47. Let's see how much different it will be for this one. So this is the meter that I usually use for capacitance measurements. It should roughly show the same thing. The reason it's showing higher in circuit is because there's some parallel resistance. 65. Yeah, that's what we got on the other one, I think, or roughly. And so this should be around 300 something. Yeah, 378. So accuracy is good. Obviously, you don't need the exact, or to get the exact capacitance, you need to remove the capacitor from the circuit. Now, I am curious, what is the frequency it uses for measuring capacitance? The higher the frequency, the higher the precision, right? Or the higher the accuracy. Typically, it's not a golden rule. So let's see, what do we have here? And the frequency is roughly 3 kilohertz. Now let's compare it to the Fluke. Fluke has a much higher frequency, if I remember correctly. Yes, Fluke has 14 kilohertz. Right, 14K. This one has 3K. And the meter that I rely on for capacitance measurements, because it's not the Fluke that I rely on, it's the cheap Chinese multimeter that I got pretty much just for this purpose. And the reason is because it has much higher range. Now this one is at 10 kilohertz. Right, so the lower the frequency, the longer it takes to make the measurement. And in addition, this is just my assumption rather than the rule, the accuracy is slightly lower if you have lower frequency. So 3 kilohertz on the frequency, and on the frequency of the capacitance meter. Typically, you probably won't be using this for measuring capacitance, and it should be completely fine. Let's see the range. Let's do 2200, and let's see if we can do it right. There's going to be some parallel resistance through my hands, and we got it, 2000. It should be 2200, but again, I'm touching it when I'm measuring. That increases the parallel resistance with the capacitor, which impacts the measurement. Now for this purpose, and this is definitely something that I like about this meter already, come on, we can connect the alligator clip and do this again properly, like so, without touching it or anything, right? And that should be more accurate reading. As you can see, it's significantly slower because of low frequency. Okay, it's still showing the same thing, so it wasn't my fingers that were causing that. Now this is 2200, so we are like 200 mics off, but it doesn't mean that the meter is that much off. The capacitors will, well, 10%, you can allow 10% difference, which is exactly, well, 220 microfarads of difference. So this is fine, right? Typically you don't use meters like this to measure accurate capacitance precisely. Now this one is 3300. So just to mention, a fluke cannot measure any more than 1000. My other meter around 3000. So let's see if this one can catch 3300. And there it is. Also slightly off, but you know, that confirms that the capacitor is working. So we have 3K. So I don't have, no, I have 4700. This one. So let's see if it's gonna go to over 4000. So none of my meters can measure this cap. None of them have the range to actually measure capacitance that high. And look at that, 4.3 millifarad. So it looks like this is going to be my new capacitance meter that will replace my Chinese fluke wannabe, as I call it, because this one cannot measure 4K, or 4K, I mean 4 millifarads. And it's 4.3, it should be 4.7. So all the measurements are slightly lower, but that might be the actual capacitance. And I can't really confirm it because this one I cannot measure with anything else. I would have to use the oscilloscope to actually measure the capacitance. So that's fine. Okay, so capacitance meter seems to be really good on this one. And this is actually something that I see often, come to think of it. Those cheaper meters working on lower frequency can just measure higher capacitance. And even my expensive, because you know the fluke is relatively expensive. It's actually pretty damn expensive. And for that price, you don't really get the higher quality, you don't get the higher precision or anything like that. They're just more expensive because it's an established brand, and they're being used by government officials and military and all that stuff, and they've been around for many years. So you're kind of paying for that. So don't expect higher precision or better performance from Fluke meters, just a higher price tag, and well, maybe higher reliability. But again, the Fluke comes with awful probes, even worse than these. I immediately, first thing that I did on the Fluke, I just replaced the probes because they were awful. All right, so this is the capacitance. Now let's see some frequencies. Let's see how far can it measure. Let's get the generator. Connect them nicely. We can already see some readings. 63 kilohertz, even though oh, very, very impressive. I'm sending a 50% duty cycle square wave of a frequency 64.551 kilohertz, and we got 64.5. Perfect. Now let's change the type. Let's change the type to sine wave. Now we are at the sine wave. It's still showing very accurately. Duty cycle doesn't matter here. Let's reduce to even 60. This is 60 even, and we have 60 even. Right, as I touch it, it might be jumping around. This is normal. And so let's start going up. 70, 80, 90, 100 kilohertz. Now this range is already enough for you to use this meter to confirm that the transistor is switching, right? That you have the control signal from the control chip going to the transistor without an oscilloscope, and the frequency, right? Typically, the highest ones that I see in the power supplies are around 160 kilohertz, and we have 160. Now let's see where the limit on this is. 260, 300, 4, 5, 6. Yeah, now it's switched the range, 0.6 megahertz, because we are at 660 kilohertz, which is correct, 0.7, 0.8, and we have 1 megahertz, 1.06, correct. Let's do 2 megahertz, perfect, 3 megahertz, 4, 5, 6, 7. Now we reduced the precision, which is understandable. Let's do 10 megahertz, and that is our limit. Let's see, what was our limit? Let's do 7 megahertz, 8. Yeah, so 8 megahertz or 7 megahertz, it looks like roughly 7 megahertz is our limit. That is pretty good, because you're not going to be measuring anything that uses 7 megahertz using the meter, right? And there's a range of oscilloscopes that come with the limitation of 10 megahertz, which means you can reliably use them up to around 50% of its capacity, so roughly 5 megahertz. Now the oscilloscope that I'm using is 100 megahertz, which I can reliably use up to 50 megahertz. And again, it's very rare that I need to measure frequency that high, but like this quartz over here, that's 10 megahertz. So with this meter, you cannot confirm that this quartz is working, unfortunately. So our limit is roughly somewhere around 7 megahertz. Now, in addition, perhaps this meter would be able to measure higher than 7. Maybe it will go up to 10. But for that, you need slightly different probes. Because at these frequencies, the impedance of the wire makes the big difference. It's a big obstacle for frequencies that high. So that's why the oscilloscope probes are coax cables, right? And the actual cable is very short, right? Because this cable is going to become an antenna. So this is probably not even a limitation of the meter, but rather a limitation of the cables, of the probes. But even though 7 megahertz, it's pretty impressive. I would say it's pretty impressive for the meter of this size, or this kind of meter. Okay, what else do we have? We have DC current and AC current, milliamps, and DC voltage. Okay, I don't expect any issues with voltages here, but let's just give it a quick test. And let's turn on, and we have very nice precision. As I'm pushing exactly 5 volts, obviously my power supply also has some precision. So we're like 3 millivolts off, right? And it could be that my power supply right now supplies 3 millivolts over. And the reason is because my power supply's range precision is only 2 decimal places, right? Here we have 3. So that is a pretty good precision. Now let's start updating. 0.1, 0.3, 0.9. Very nice. Let's go all the way to... This is the highest voltage I can achieve on this power supply. And works perfectly fine. I just want to set it back to 5 volts because I hate leaving the leaving the high voltage on the power supply, and then I forget it and I connect something and I fry it up. Never happened, but it could. Okay, so I guess the final thing, this is true RMS, AC true RMS. Now this means I'm not going to be able to, I don't think I'll be able to show it to you. Actually, I could. So, true RMS AC voltage. That means, by the way, this meter has 4,000 counts, if I remember correctly, which is exactly the same as this one. Right, 4,000 counts. If you require higher precision, You probably aim at least 6,000 counts. I would recommend 10,000 counts. Those are going to be precision meters, because what you need this for is to measure the output power of the amplifier. So what you do, you just supply a input signal as a sine wave, maybe on 50 hertz, 100 hertz, well, 1 kilohertz. It's going to vary, right? The output power is going to vary based on the frequency. But what you want to check on this one is the true RMS voltage on the output. That tells you the true RMS power of the amplifier. Now, I don't have any amplifier handy right now to measure that, but what I can do is connect the oscilloscope signal generator, which will emit 1 kilohertz. Now, I don't need to, in this case, I don't need to connect the ground because my probe is in the DC mode. So all I have to do is just connect this here, right? It shows 0.84, right? So 8 millivolts. What we expect is 900 millivolts, and this shows 850. So it's off, at least compared to my oscilloscope, it's off by roughly 50 millivolts, which is not too bad, at least at this range. Now let's reduce the frequency. Still 900 millivolts, 850. So roughly 50 millivolts off. But now the question is my oscilloscope 850 millivolts off? It could be. Or this one is 25 millivolts off and oscilloscope is 25 millivolts off, which they kind of meet in the middle, right? But accurate enough. So I would be able to actually measure the output power of the power amplifier. So this, in a way, can replace your oscilloscope in certain situations, which is very nice. What else do we have? Resistance. So let's check the resistor. Now, resistance meter is the most basic one, and in many cases you want to be relatively accurate with resistance, but in very rare cases. So this is 4 ohm resistor, which shows up as 3.8. Good enough, I would say good enough. And we have 1.8, so these are two 4 ohm resistors in parallel, which makes one 2 ohm resistor, and we're seeing 1.8. Again, good enough. I would expect that the resistance will be higher because of the resistance of the probes. And let's see the resistance of the probes. It's showing nice 0, so you know, if you want to find dead short, you can do so. No problems there. Okay, and the beeper we already checked. Actually, the beeper on this one is the true star. All right, the fluke cannot do that. With fluke, I have to actually hold it for a little while. This one reacts immediately. This is very handy, as I said, for checking the connectivity. Now we can see with the right. I actually need to. It's not too bad. The fluke is not too bad, but this one seems to be slightly faster, or at least as fast as fluke for that. So this is definitely a star of this meter. and massive functionality. I would actually say that it has a lot more feature than I would expect from the multimeter, or I would want from multimeter. You know, I really don't care about the calendar and temperature and humidity. On the other hand, it's useful to know what the humidity of your environment is, depending on what you work on, what you're working on, right? So this is not bad. And there's let's see that mode over here. Oh, what is this? 11:20. Oh, so that's the day, month, and the day. Okay, 22nd of okay, it's off, but it's fine. We have an alarm clock. I wouldn't mind if it had a timer, right? Because sometimes, obviously, all of this, I have separate tools for that. So for the timer, I have my phone. For the, you know, the, what do you call it? The actual time, the clock, I have the actual clock on the wall, right? For humidity, well, actually, I don't have anything for humidity, but typically you would have something like that in your shop as well, as well as the temperature. So it might seem like a kind of a, why are you putting it in here? The same with the clock, right? With the alarm, it's packed with features that typically you don't need on the multimeter. But since it's already here, you know, it's kind of fun. It's kind of fun. I might actually use that. And now for the same reason, how do we can turn it off? Oh, you gotta hold probably. Okay, you hold, you turn it off, but your clock and everything else still shows. So this is not bad. I'm really glad they fixed the orientation, because before the orientation was this, which is just not practical. Now the orientation is like this, and it really, it's a really nice device. And it doesn't really matter what it looks like. What matters is how it works. And as you can see, you can perform all the measurements that you would with Fluke or an expensive multimeter, and the capacitance meter goes above and beyond. I did not expect that it would go over 4 millifarads, but it can probably go even farther than that, but there's really no need for measuring capacitance over 4 millifarads. Why would you, right? This is actually pretty useful when you work on the power supplies, because the output capacitance on the power supplies will be very high, and it could be well over 4 millifarads, which means when you connect like Fluke or my Fluke wannabe, they're gonna show open line. They're gonna show you the progress, the measuring of measuring the capacitance, but it'll show OL. Which, yeah, I call it open line, but it's also interpreted as over limit, which in this case is the capacitance is just over limit. So very nice. Also, the price on them. The price is you can buy several of these for the one price, or for the price of one Fluke. Which means you can just use them as disposable meters pretty much. It's portable, all right. It came with a lot of accessories, which I absolutely love. And the measurements, I'm happy with it, because I don't need super high precision. But even for the cheap device like this, I'm surprised how precise it is. It's a very nice device. If you're looking for a meter, well, this is all you need. It's a little different than typical meters that you that you are used to, It's a very nice size. It's about a size a little smaller than the ESR meter, than the Messer 100. It's slightly bigger than, well, it's pretty much the same size as my capacitance meter, or what I use for capacitance. Alright. Looks nice. The majority of its weight are the batteries, but once you put the batteries in, it feels nice. It has the proper weight. Enough that it's, you know, it's not going to be just jumping on your desk, or, you know, you're not going to knock it over by just touching it. You can operate the buttons without holding the meter. This seems like a very, why would that matter? But it is, especially for my oscilloscope, it is especially annoying. That's why I have it screwed on, literally screwed onto the wall, because you cannot press any buttons without holding the oscilloscope, because it's not heavy enough. So this is designed in a way that you can press the buttons without moving, without actually holding the multimeter. And this is very often you have probes in one hand and you hold it like this, and you just want to switch the modes or something like that. You don't have the other hand to hold the multimeter. So this works. The previous version that was sitting like this did not, you know, couldn't do that. So we can see a very good improvement from this, and I think the next version following this one is going to be even better, because they definitely go in the right direction with the multimeters. And these buttons that you do need two hands to click, these are non-essential, right? This only controls the stuff that you typically don't need. 85 degrees Fahrenheit. That's our temperature today, Georgia. Alrighty. This is recommended by Black Horse Repairs. It gets the job done. Definitely recommended. And I will be using it, so you'll be seeing it on my bench. And I will actually try to use it for the next, like solely just this one, for the next, I don't know, few days, maybe a few weeks, to possibly, you know, uncover any issues that you might encounter during the operation. So if you guys have any questions regarding this meter, definitely drop them in the comments. I can always ask the manufacturer if I can figure something out, or you need more information that is not presented in the data sheet. Perhaps I can acquire that information for you. But considering the price of it, and I don't remember the price of it, but I think it was around 20 bucks, maybe 30 bucks, something like that. But you know, the Fluke is going to cost you anywhere from like 80 bucks to, well, actually no, I think 130 bucks is the lowest price, and I got mine for a little less than $200. This is not the cheapest version, but not the most expensive version either. I aimed somewhere in the middle. This one is also not the cheapest one, but not expensive, not the high shelf either. And it gets the job done. It's absolutely recommended by me, and I will start using it. And if there are any issues, I'll let you guys know. But for now, this is absolutely recommended. Very good job to, how do you pronounce that? Aneng? Whatever. 613 is the model, and that's all we need to know. And it works great. Alrighty, guys. Thank you very much for watching. I do appreciate you. And if you need a multimeter, budget multimeter, this is going to satisfy your needs as far as typical work that you do on the bench. And with that, thank you very much, and I shall see you guys in the next one.